So we're going to look at number 20 here. We're taking 136.0 gram ice. We're taking it from negative 15 degrees Celsius to 50 degree Celsius water. Okay, temp. So when we're doing this, we're thinking about that heat curve that we talked about in our phase changes, that you can have something frozen right here. It flat lines at 0 degrees, and at this point is where it's melting. And then it comes up, and at 100 degrees is where it starts vaporizing, okay? So we're keeping this thing in mind as we go through. So right now I'm down here at negative 15 degrees Celsius. I'm needing to go from negative 15 to 0.0. Sorry, let me make that be 15.0 like the book. So I'm going from negative 15.0 to 0.0 degrees Celsius. Okay, this involves a temperature change. So when I'm wanting to know the heat for that, I'm going to see that Q equals MC delta T. So I put my information over here, make sure I have it all. My delta T is going to be 15.0 degrees Celsius. My C at this point is going to be that C for the ice that they gave us. So we're going to use 2.093 joules per grams degrees Celsius. And that mass is 136.0 grams they gave us. So we put in the 136.0 grams. We put in the 2.093 joules over grams degrees Celsius. And we put in the 15.0 degrees Celsius. Our Q, once we multiply all that out and hold it to the 3 sig figs of 15.0, ends up being 4270 joules. So that's our first thing. Now, that just gets us to 0. Now, at 0, it's going to take some energy to melt all our ice. Well, this is going to be a latent heat then. That is meaning that we have a phase change. We have no temperature change. So we can't go use this temperature change equation because we don't have a temperature change. We have a phase change. So the heat for the phase change is going to be the mass times the L. Well, what L do we use? If we're going from a solid to a liquid, we use the L sub F. And that was given us 334 joules per gram. So our mass ends up being the same. We use the 136.0 grams. And we're going to take that times 334 joules per gram. The grams cancel. We're going to have 3 sig figs according to that. So we will make that 45,400 joules. So that's the second little piece. So we've decided how much energy it gets just to get us here, how much energy it does to melt all the ice. Now we're going up really about halfway here. We're only going to 50. So that is a temperature change. We're at 0 degrees. We're going to 50 degrees Celsius, 50.0. Okay. So we know that our delta T here is going to be 50.0 degrees Celsius. This time though, we are in the water phase right here. We're in the liquid phase, so that'd be water. We're going to use our 4.184 joules per gram degrees Celsius. Okay. So we have our delta T or C that we need for this. We know the energy then, because we have a temperature change, we go use the temperature change energy part. And we have 136.0 grams. We have 4.184 joules per gram degrees Celsius. And we have that temperature change of 15.0 degrees Celsius. So we multiply each one of those. Grams cancels, Celsius cancels, we end up with joules. We want 3 sig figs because of the 50.0, so that gives us 28,500 joules. Okay, So here's what we've done. We've taken it, the temperature from here to here, which is a temperature change. We found that. Then we went and said, oh, there's this latent heat for while it's melting. In the phase change, what's happening? So the phase change, we go through and put that in there because it is the L sub F. We're going from solid to liquid. If you are going from liquid to solid, you'd use the same thing. And we then we know we're going from 0 up to 50, about halfway till we get to that boiling point. So we just put in that, but we are in the water phase now, so we need to use the C for the water phase. So that's kind of the whole process. Now in the book, we went and did one all the way to vaporization, which means we would have been going to 100 degrees and past. So if we were doing vaporization here, we would go from 0 to 100. But then we would have a latent thing here too, using L sub V, because we would have wanted to vaporize it all. So as you're considering it, you're just really thinking about where you're going, where are you starting, and where are you going on this path. Okay, there was also one on your own that you had to do where it was already at 0, so you didn't have anything you had to figure out in advance. You just figured out the latent heat to start to get it all melted. Then you moved it up to here, and then you had to do the vaporization to get it all to turn to vapor. So just think about where you're at in your journey. If there's a temperature change happening, you use this. If it's a latent heat phase change, you're going to use Q equals ml and use the appropriate L. So hopefully that helps you with problems like number 20.